A, and there this solution ends. And now we come to the final exercise. The statement is long, but the solution is not that long. Let's see what it says. Show assuming the other axioms of set theory. That the universal specification axiom axiom 3.8 is equivalent to an axiom postulating the existence of a universal set, postulating the existence of a universal set omega of all objects, that is, for any object x. I need ink. Give me a moment. That is, for an object x, for any object x, we have x belongs to omega. So this is the exact opposite of the empty set. In case of empty set, for any object x, x does not belong to the empty set. Here x belongs to the universal set. And note that this is the set of all objects. Okay. In other words, if we assume the axiom of universal specification, it implies that a universal set exists, and conversely, existence of a universal set implies that's axiom of universal specification. This may suggest why axiom 3.8 is called the axiom of universal specification. Okay, anything else? This is important. This is just something that Tao has written along with this exercise statement. However, what he says is important. Note that actually the exercise ends here, but there is a consequence. If a universal set omega exists, then omega belongs to omega. Why? By axiom 3.1. You see, universal set exists means omega is a set, and according to our first axiom, sets are objects. So that means omega is an object, and since by definition omega is the set of all objects, so in particular omega will contain itself, and this will contradict the previous exercise. Why? Because in the previous exercise we have already proved that no set contains itself as an element. So what is the conclusion of this? It says that first of all, this exercise tells us that the axiom of universal specification, axiom 3.8, is equivalent to the existence of a universal set. And if a universal set exists, then we run into a problem. That means the axiom of specification cannot be true. I mean, the axiom of universal specification cannot be true. Or, more specifically, it cannot be true in the system of axioms that we are developing for set theory. If we combine it with the other axioms, we get contradiction like this. And there is one more thing. Now the conclusion is that after all, axiom 3.8 cannot be true if we consider it along with the axiom of foundation, that is the axiom 3.9, regularity axiom. And since Russell's paradox is a consequence of the axiom of universal specification, now because of this we have gotten rid of Russell's paradox. That's how Russell's paradox is settled. It does that, if you recall, that set of all sets not containing themselves, that type of collections are not sets anymore. So we don't have Russell's paradox. Thus the axiom of foundation specifically rules out the axiom of universal specification. That is the final remark about this exercise. And now we come to the solution. Solution is rather easy actually. First we assume axiom 3.8. Okay. Let, that means we now have the axiom of universal specification. We have to somehow conclude that a universal set exists. Let Px be the following property pertaining to any object x. X is an object. Okay, x is an object. So then clearly Px is true for every object x, because that's what it says, that x is an object. By axiom 3.8, the following set exists: x such that P of x is true, which according to the definition of omega equals omega, because it is the set of all objects, which is the definition of omega, and that's how a universal set exists if we assume axiom 3.8 to be true. Conversely, assume that a universal set omega exists. Then, by the axiom of specification, which is axiom 3.5, the following set exists for any property, say Qx, x belonging to omega such that qx is true. Okay, I should have written about qx before writing this, but anyway, here we in the second part we have assumed that there is a universal set and we are given any property qx pertaining to any object x whatsoever. Then since x is an object, x belongs to the universal set, and by the axiom of specification, not universal specification, by the axiom of specification, which is axiom 3.5, this set exists. It is the set of those objects in the universal set which satisfy the property Q. But since objects in the universal sets are all objects, so we get this. It is easy to see that this set equals this. And this is what the axiom of universal specification states. This is the axiom of universal specification, and that's how this solution and this section ends. Okay, so in the next section we will look at the concept of functions. So this is me, the caretaker Lucifer from the mathematical room, signing off for tonight. Have a nice night.